Hey everyone, and welcome back to the AI Tech channel. Today, we're diving into something that's been quietly powering the internet for almost 2 decades, Amazon S3. Can you believe it? S3 is turning 19. 19 years of storing our photos, videos, and, well, pretty much everything. But here's the burning question. Has S3 stayed true to its original promise of simplicity, or has it become a bloated beast of features and complexity? That's what we're going to unpack today. Back in 2006, when S3 launched, it was a breath of fresh air. A simple object store, put, get, delete, list. For verbs that revolutionized how we thought about storage. I remember those days, setting up my own servers, worrying about capacity, and praying the hard drives wouldn't fail. S3 just took all that away. But things have changed. A lot. Now, S3 boasts hundreds of features, options, and configurations. Has this evolution made it better, or just more complicated? To celebrate S3's 19th birthday, Andy Warfield, VP and distinguished engineer at S3, published a fascinating blog post reflecting on its journey. He emphasizes how customer feedback has shaped S3's development, driving new features and improvements. He argues that S3's core mission is to abstract away complexity, allowing developers to focus on their core business logic. But is this really the case, or is the sheer number of options now overwhelming? Let's dig deeper. When Andy joined the S3 team in 2017, S3 had just crossed 1 trillion objects. Today, it stores hundreds of trillions across 36 regions globally. That's insane growth. It's become primary storage for virtually every industry. Think about that for a second. Everything from your cat videos to critical business data lives on S3. This scale demands constant evolution, but at what cost to simplicity? Warfield highlights that almost every popular S3 feature is a direct response to customer requests. Things like strong consistency, conditional operations, and increased bucket limits were all driven by builders needing more from the service. This customer-centric approach is commendable, but it also raises a concern. Are we adding features just because we can, even if they add to the overall complexity? He argues that simplicity in S3 isn't just about the API. It's about making S3 invisible. You shouldn't have to worry about provisioning capacity, running out of space, or managing infrastructure. Elastic scale, high durability, and availability should be taken for granted. I agree with this in principle, but the reality is often different. How many of you have spent hours wrestling with IAM policies, lifecycle rules, or cross-region replication settings? These aren't exactly simple. The move to strong consistency was a game changer. Customers were thrilled because it allowed them to delete code and simplify their systems. No more worrying about eventual consistency and race conditions. This is a perfect example of a feature that actually reduced complexity. But what about features that add complexity, even if they provide new functionality? Warfield mentions that the S3 team learns a lot from startups building on top of S3. These companies often push the boundaries of what's possible and provide valuable feedback on how to improve the service. He specifically mentions TurboPuffer, a serverless vector database built on S3. These early adopters are crucial for identifying pain points and driving innovation. But are their needs representative of the broader S3 user base? He shares a funny anecdote about customers guessing at new S3 APIs and writing scripts to probe for them. This level of enthusiasm is a testament to S3's importance, but it also suggests that there's a demand for features that haven't been officially released yet. Are we launching features fast enough to meet customer needs, or are we lagging behind? The increase in bucket limits is another example of a seemingly unglamorous launch that builders got excited about. Previously, there was a limit of 100 buckets per account. This was a historical artifact that no longer made sense. Removing this limitation allowed customers to use buckets as a programmatic construct, sharing datasets with their own customers. This is a clear win for simplicity, but it also highlights how seemingly small limitations can have a big impact. Scaling bucket limits required significant engineering effort. The bucket metadata system, called MetaBucket, had to be rewritten to handle millions of buckets per account. This involved addressing performance concerns in the AWS console and introducing a new paged version of the List Buckets API. This shows that even seemingly simple changes can have complex implications at scale. The underlying architecture uses a distributed hash table, DHT, similar to Cord, Stoica, R, Morris, R, Karger, D, Koshoek, M, F, and Balakrishnan, H, 2001. Cord, a scalable peer-to-peer lookup service for Internet applications. ACM SIGCOMM Computer Communication Review, 31, 4, 149 to 160. This DHT ensures efficient lookup and management of bucket metadata across the vast S3 infrastructure. The team discovered that rendering the list of S3 buckets in the AWS console could take tens of minutes to complete with large numbers of buckets. This required collaboration across multiple AWS services to address the rendering issue. This is a great example of how seemingly isolated changes can have cascading effects on the entire ecosystem. This also highlights the importance of considering the user experience when making architectural changes. As S3 evolved from archival storage to a more capable system, customers demanded more performance. This created a flywheel effect, where improvements in performance drove demand for even more performance. S3's approach to performance is based on the principle of elasticity. Any customer should be entitled to use the entire performance capability of S3, as long as it doesn't interfere with others. This requires sophisticated automations and guardrails to prevent abuse. This is a classic example of a resource allocation problem, often addressed using techniques like fair queuing, Parekh, AK, and Gallagher, R.G. 1993. A generalized processor sharing approach to flow control in integrated services networks, the single-node case. IEEE/ACM transactions on networking, 344 to 357. And weighted fair queuing, Demers, A. Keshav, S. and Schenker, S. 1990. Analysis and simulation of a fair queuing algorithm. ACM SIGCOMM Computer Communication Review, 24, 1-12. S3 documents everything from request parallelization to retry strategies and builds these best practices into the common runtime, CRT, library. This allows customers to drive massive performance from their data without imposing complexities like provisioning. Individual GPU instances can use the CRT to drive hundreds of gigabits per second in and out of S3. This is a significant achievement, but it also requires a deep understanding of network protocols and distributed systems. The launch of S3 Express One Zone in 2023, the first SSD storage class, was driven by customer demand for lower latency. This single AZ offering minimizes latency for interactive workloads. Machine learning customers like Anthropic are driving tens of terabytes per second, while entertainment companies stream media directly from S3. This highlights the diverse range of use cases that S3 supports. The underlying architecture utilizes a technique called erasure coding, Planck, J. S. 1997. Erasure codes for storage applications. IEEE Micro 17, 1, 62-72. To ensure data durability and availability even with SSDs. Warfield makes a self-critical observation. Improvements toward simplicity are often improvements against initial features that weren't simple enough. There's a tension between simplicity and velocity. Racing to release something with painful gaps can frustrate early customers, while over-designing can prevent you from ever shipping anything. This tension is a constant source of debate within the S3 team. This is a fundamental challenge in software development, balancing the need for speed with the need for quality and usability. People have been storing tables in S3 for over a decade using formats like Apache Parquet. Over time, Parquet evolved to support connectors for popular analytics tools, but developers wanted a richer table abstraction with finer-grained mutations and evolving schemas. This led to the development of open table formats like Apache Iceberg. Iceberg introduced a metadata layer to build a table construct that could be composed from S3 objects. It represents a table as a series of snapshot-based updates, allowing for small updates without rewriting the whole table and enabling versioning. This is a clever solution, but it also introduces complexity. Because Iceberg's structure is externalized, customer code manages the relationship between data and metadata objects, performing tasks like garbage collection. This can lead to fragmentation and performance issues. Existing S3 features like intelligent tiering and cross-region replication don't work exactly as expected on Iceberg tables. This highlights the limitations of building abstractions on top of existing services. Customers operating highly scaled databases over Iceberg expressed enthusiasm for the richer table abstraction, but also frustration with the responsibility for compaction, garbage collection, and tiering. They asked why S3 couldn't do more of the work to make the experience simpler. This feedback led to the launch of S3 tables. S3 tables integrate Iceberg with S3. Each table surfaces behind its own endpoint and is a resource from a policy perspective. APIs simplify table creation and snapshot commit operations. By understanding how Iceberg laid out objects, S3 can make internal performance optimizations. This is a significant step towards making tables a first-class S3 construct. The transformation of an object store to support tables is a huge shift. It has significant implications for how we all work with data, and it all comes back to this question. Is this progress or just more complexity? I think that the answer is, like most things in life, nuanced. Let me tell you why. If you're the kind of person who wants to build your own custom solution on top of an object store, then you're probably not that excited about any of this. And if that's you, I want to encourage you to keep building. The world needs people pushing the limits. But if you're like me and you just want to get your job done without having to become a distributed database expert, then this kind of thing is transformative. The ability to have a managed data lake with ACID, atomicity, consistency, isolation, durability, transactions is something that would have been science fiction just a few years ago. And the fact that S3 is now offering this is a testament to the power of software and the power of customer feedback. Now, let's be real, S3 has a lot of features, and I mean a lot. It's easy to get lost in the weeds, trying to figure out which storage class to use, how to configure lifecycle policies, or how to optimize your data for cost and performance. The sheer number of options can be overwhelming, especially for newcomers. I think we can all agree on that. So, what does the future hold for S3? I think we'll see a continued focus on performance, new storage classes optimized for specific workloads, and even deeper integration with other AWS services. The challenge will be to maintain simplicity while adding new features. It's a delicate balancing act, but I'm confident that the S3 team is up to the task. And remember, if you're feeling overwhelmed, remember the core principles. Put, get, delete, and list. Sometimes, it's good to go back to basics. What do you think? Has S3 become too complex, or is it still a simple and powerful storage solution? Let me know in the comments below. Also, be sure to subscribe to the AI Tech channel for more insights and analysis on the latest trends in cloud computing and artificial intelligence. Thanks for watching.